Complementary trigonometric functions explained.
Let's start at the origin, point O. We draw a segment of length 1 on the x-axis. If we rotate this segment, its endpoint traces a circle of radius 1, the unit circle. We fix the line at an angle. This new point is P. The key rule is, here, the x-coordinate of P is the cosine of the angle, and the y-coordinate is the sine. Let's project P. On the y-axis, we get A. On the x-axis, we get B. Now, let's draw the line tangent to the circle at point P. Observe the right triangle OPC. We know that OP, the radius, is equal to 1. That is, cosine equals 1 over OC. If we solve for OC, we find that OC equals 1 over cosine. This ratio, 1 over cosine, has a special name. It is the secant of the angle. Let's show that label on segment OC, secant. Now, what is the length of segment PC, the side of the triangle from P to C? We can calculate it using the distance formula between the 2 points P and C. By expanding that formula, applying the binomial expansion and simplifying, we arrive at a remarkable expression. The distance PC is equal to the square root of secant squared minus 1. And by trigonometric identities, that expression simplifies further. The square root of secant squared minus 1 is exactly equal to the tangent of the angle. Thus, segment PC, this side of the triangle on the tangent line, has a length equal to the tangent. Let's continue the tangent line beyond point C. If we extend it upward, we see that it also intersects the y-axis. Now, observe the right triangle OPD. In this new triangle, side OP is still our radius, which is 1. That is, sine equals 1 over OD. Solving for OD, we find that OD equals 1 over sine. This ratio, 1 divided by sine, also has a special name. It is the cosecant of the angle. Let's show that label on segment OD, cosecant. Now let's calculate the length of the other leg, segment PD, which goes from point P to the y-axis. We again use the distance formula between the 2 points P and D. By expanding the terms with the binomial expansion and simplifying step by step, we arrive at a very clean result. The distance PD is equal to the square root of cosecant squared minus 1. And by trigonometric identities, this expression simplifies to give us a familiar value. The square root of cosecant squared minus 1 is exactly equal to the cotangent of the angle. Therefore, segment PD, this side of the triangle on the tangent line, has a length equal to the cotangent. Let's show that label, cotangent. Save this for your next study session.